Hey, what's up guys? This is part 2 of Equilibrium of Forces in Space. I'll be going over the final two problems in Vector Mechanics for Engineer Statics, 11th edition. If you do find these videos to be helpful, be sure to like and subscribe. Thank you for listening, and let's get on to the fourth problem. For the fourth problem, we have a rectangular plate as supported by 3 cables as shown. Knowing that the tension in cable AD is 520 newtons, determine the weight of the plate. For the first step, I'm just going to redraw the coordinate system along with the free body diagram. I've already drawn it out, so I'll just tell you how I did the forces. So I drew the free body diagram at point A. We have 3 tensions: tension AB, tension AC, tension AD, as well as a vertical force P. And the reason why I drew the vertical force P is because P is equal to the weight of the plate. So if we solve for P, we can find the weight of the plate. Alright, so if you recall from a previous video, tension AB, for example, is equal to, which is a vector, is equal to its magnitude, which is a scalar, times lambda. And we can simplify this into the magnitude of tension AB times the vector AB over the magnitude AB. So what I want to do is find the vectors for all the tensions first, and then get the magnitudes. Vector AB is equal to So vector AB is equal to minus 320i, minus 480j, minus 360k. And its magnitude is equal to 680 millimeters. And the diagram got cut off, but all of the dimensions are in millimeters. Vector AC is equal to 450i minus 480j minus 360k, and its magnitude is equal to 750 millimeters. Finally, vector AD is equal to plus 250i minus 480j plus 360k, and its magnitude is equal to 650 millimeters. So now, using this equation, I'm simply going to substitute in the values for the vectors and the magnitudes. So this will give you tension AB is equal to its magnitude times vector AB over its magnitude. And this can be simplified into tension AB times vector AB over the magnitude AB, which is 680. So now we can simplify this even further, and this will give you minus 8 out of 17i, minus 12 out of 17j, minus 9 out of 17k, times tension AB. So I'm simply going to do the same thing for the other 2 vectors. And this is equal to the magnitude tension AC times vector AC. all over the magnitude of vector AC, which is 750. And this can be simplified into (6 out of 10I minus 16 out of 25J minus 12 out of 25K times tension AC. And finally, for tension AD, it's equal to the magnitude of tension AD times the vector AD, which is all over the magnitude of vector AD, which is 650. This can be simplified into (5 out of 13I minus 48 out of 65J plus 36 out of 65K times tension AD. So now that we have the tensions, we can solve for the sum of the forces in the x, y, and z direction. The sum of the forces in the x direction would be equal to minus 8 out of 17 times tension AB, plus 6 out of 10 times tension AC, plus 5 out of 13 times tension AD, which is equal to 0. So we could do the same for the sum of the forces in the y and z direction. The sum of the forces in the y direction would be equal to the summation of all the j components. And that's equal to minus 12 out of 17 times tension AB, minus 16 out of 25 times tension AC, minus 48 out of 65 times tension AD. And finally, we have a positive P force going upwards, so don't forget to include that too. And this is equal to 0. Lastly, the sum of the forces in the z direction is equal to the summation of the k components. So the sum of the forces in the z direction would be equal to minus 9 out of 17 times tension AB, minus 12 out of 25 times tension AC, plus 36 out of 65 times tension AD, which is equal to 0. It's given to us in the problem that tension AD is equal to 520 newtons. Therefore, since we have 3 equations and 3 unknowns, we have a few ways to solve these problems, but in this example, I'm going to solve it using substitution. So now starting off with the sum of the forces in the x direction, So as you can see, I simplified this expression and solved for tension AB in terms of tension AC. And the reason why I did that is because I want to plug this into the sum of the forces in the z direction and solve for tension AC. So equating the sum of the forces in the z direction. So now taking the expression that we saw for previously, we can plug in tension AB into this equation, and this will give you tension AC is equal to 54.55 newtons. Since we know what tension AC is equal to, I can plug this back into this equation and solve for tension AB. So plugging in 54.55 into tension AC, tension AB is equal to 494.55 newtons. So now we can finally solve for the vertical force P, because we have all the other tensions. Sum of the forces in the Y. And this is equal to 0. So now plugging in the values for the tensions, we can solve for the vertical force P. P is equal to 768 newtons. And again, the reason why we solve for P is because the vertical force P is equal to the weight of the plate. So I just zoomed out so you guys can see the problem from start to finish. For the fifth and final problem, we have a transmission tower is held by 3 guy wires attached to a pin at A and anchored by bolts B, C, and D. If the tension in wire AC is 590 pounds, determine the vertical force P exerted by the tower on the pin at A. So question 4 is pretty much like question 5. We have 3 cables as well as vertical force P. Like we've done previously, I want to set up the coordinate system first, as well as the free body diagram at point A. Alright, so here's our point A. We have tension AB, tension AC, tension AD, as well as a vertical force P. Like the previous problem, I want to get the length of the vectors along with the magnitudes. Vector AB is equal to minus 20i, minus 100j, minus 25k. The magnitude of vector AB is equal to (105 feet). Vector AD is equal to minus 20i, minus 100j, plus 74k, and its magnitude is equal to 126 feet. Finally, vector AC is equal to vector AC is equal to 60i minus 100j minus 18k, and its magnitude is equal to 118 feet. We know that the vector tension AB is equal to its magnitude times vector AB over the magnitude AB. So now we can substitute in the values. And this gives us and simplifying this we get minus 4 out of 21i minus 20 out of 21j minus 5 over 21k. And I'm just going to do the same thing for the other two tensions. So simplifying this expression we get minus 10 out of 63i minus 50 out of 63j plus 37 out of 63k times tension AD. Finally, tension AC will give us and simplifying this expression, we get So now that we have the equation for the tensions, we can have the sum of the forces in x, y, and z direction and solve for P. So now I want to equate the sum of the forces in x, y, and z direction. So the sum of the forces in x direction would be equal to the summation of all the I components. So the sum of the forces in x direction is equal to minus 4 out of 21 times tension AB, plus 30 out of 59 times tension AC, minus 10 out of 63 times tension AD. And this is all equal to 0. We're going to do the same for the sum of the forces in the y direction. And this is all the j components, and we're summing them up. And this is going to give us minus 20 out of 21 times tension AB, minus 50 over 59 times tension AC, minus 50 over 63 times tension AD. And finally, we also have a plus P, because we have a vertical force P going up. Lastly, we have the sum of the forces in the z direction, and this is equal to the summation of all the k components. So the sum of the forces in the z direction is equal to minus 5 over 21 times tension AB, minus 9 over 59 times tension AC, plus 37 over 63 times tension AD, which is equal to 0. It's given to us in the problem that wire AC is 590 pounds. Therefore, in this case, we have 3 unknowns and 3 equations. There's a few ways to solve this, but I'm just going to use substitution. Therefore, using the sum of the forces in the x direction, I'm going to solve for tension AB in terms of tension AD. So sum of the forces in the x direction is equal to So I've simply just substituted in the value for tension AC into this equation. And solving for tension AB in terms of tension AC, this will give us So solving for tension AB, we get 1575 minus 5 out of 9 times tension AD. So using this expression, I want to plug this back into the sum of the forces in the z direction and solve for tension AD. Now I'm just going to plug in the expression for tension AB. Times 590, which is given to us. So now from this expression, we can solve for tension AD. So solving for tension AD, we end up with 591.82 newtons. So tension AB is equal to 1081.82 newtons. Finally, since we have all three tensions, we can solve for the vertical force P. So we need to use the sum of the forces in the y direction and solve for P. So substituting in the values for all the tensions, we were able to solve for the vertical force P. And for us, P was equal to 2000 newtons. Alright guys, that's it for today's video. In the next video, I'll be covering Chapter 3, Rigid Bodies. If you do like these videos, make sure to like and subscribe. Thank you so much for listening, and I'll see you next time.